Good morning, dear students. Today we want to start a new chapter, that is circles, and its important property in the form of theorems. So, can you give some examples about circles? Yes, a very good example. You can observe that the bangles and the coins and wheels of the cycle or wheels of the motorcycle and some of the clocks. Is it? These are the examples related to circles. So many examples you can give because already you have studied some related definitions also. Yes. Just today also just want to remind what is circle and what are the related terms. Yes. Circle and its related terms in lower classes to define. Yes. So now one example I want to give you. When a clock which is in the form of circular or circle, minute hand or second hand or hour hand. Second hand always rotating, but with one condition, one point is fixed and tip of that second hand is only moving. Is it? So that fixed point with the tip, is it? So tip is revolving in a particular distance. So when a point or tip moves with a particular way with a fixed point forms a circle. So we can tell circle is formed by the locus of a point which is fixed and the distance is also fixed. Is it? So circle definition generally we are telling, that is from the fixed point, when a point or a tip or whatever object is revolving in a particular way forms circle or circular disc. Is it? So now just you can understand that this is compass. You know very well that, just I am reminding, this is the point that is denoted by O. Yes. So now this is said to be a fixed point, this is said to be a point moving. So from a fixed point, some particular distance a point is moving forms a circle. Yes, this is the instrument used to draw a circle. That is now known as compass. Without this, there is no compass. That is only compass box. Is it? So now this is circle. So what are the related terms? The first point is that center of the circle O, then circumference. And second point is arc, and third point is radius, and fourth point is diameter. Next point is chord. Next point is sector or segment, and next point is a sector. Yes, these are the terms related to circle. Okay, so now we want to draw these all in a circle. Now, circumference of this circle. Circle is denoted by the center. Fixed point is said to be center of the circle. Yes. So now this is said to be boundary of the circle is known as circumference of the circle. Circumference of the circle. So circumference circle, how to find the length of the circle by the help of formula, that is equal to C equal to 2 pi r or pi d. This is a formula to find the length of the circumference of circle. What is the pi? Pi is constant value, that is 22/7. That already was studied how we can measure and how we can prove that constant it is 22/7 or 3 point, like that. Yes. Next, arc. Yes. So now A is a point, B is a point on the circumference of circle. A and B are said to be 2 points on the circumference of circle. Then AXB is said to be an arc. It means part of the circumference of circle. Part of the circumference of circle is said to be arc. You should not read AB is arc. AXB is an arc. AB, what happens now? AB for reading, it happens chord. AB is chord. Now AXB is not a chord. AXB is an arc. AB is chord. So now remaining part of that AXB, there is some again AYB. AYB. See? AXB is a part of circle. AYB is also part of circle. Circumference circle. So these are two arcs. This is smaller. AXB is smaller than the AYB. So it is called minor arc. This is called major arc. So there are minor arc and major arc. Can you understand that? Yes, major arc, minor arc and major arc. It means 2 points of the circumference, 2 points which are on the circumference circle divides into 2 arcs. One is minor, one is major. Okay. And radius. Radius. O is the center of the circle. P is any point, anywhere on the circumference of the circle. The distance between center and circumference. Center and circumference is called radius of the circle. This is one example, one question. How many radii can be drawn in a circle? Yes? How many radii can be drawn in a circle? How many points are there in the circumference? Infinite. Not only 3, 4, 5, 6, 7, 8, 9. Like that. No. Infinite set of points which are equidistant from a fixed point forms a circle. Yes, so infinite number of radii can be drawn, and whatever the number of points which are on the circumference circle are equal. It means from the fixed point. So all radii are equal. Very important point. Infinite number of radii can be drawn in a circle, and all radii are equal. Radius is the distance between center and any point on the circumference of circle. Okay. On the circle you should remember circumference only. And also you can tell, now if it is in this way writing that this is part interior, this is part exterior. It means what? Interior and exterior. Okay. Now radius. What is diameter? Diameter. Yes. Before that, first we are going to define chord. Chord. So now A is one point, B is another point. AB is called a chord. AB is called chord. What is that? The distance between any 2 points on the circumference of circle is chord. So once again, how many chords are there? Infinite number of chords. Properties: when it moves towards the center, length increases. When it is going away from the center, length decreases. And if a chord passing through the center, if it is a chord passing through the center is called diameter of the circle. It's called diameter of the circle. So Diameter properties. How many diameters? Infinite number of diameters. Yes, 0. Diameters. Yes, infinite number of diameters can be drawn. Diameter is here. This is radius. This is radius. So diameter is always 2 times of the radius. Radius is half of the diameter. This is the relation. Yes, radius is half of the diameter. Diameter is 2 times the radius. Yes. So now diameter divides the circle into 2 equal parts. 2 equal parts are said to be semicircles. Said to be semicircles or semicircular regions. Okay. Now segment. Semi-segment also you can tell. Semi-segment also you can tell. Yes, it's a circle. Now, P is a point, Q is a point, PP is a chord. P is a point on circumference, Q is a point on circumference. When you are joining that, it's said to be a chord. So, chord divides circle into 2 parts, not equal. You can tell. Diameter is also biggest chord. So, depends on the position of the chord, you can tell equal or unequal. If it is not on the center, unequal parts. If it is on the center, equal parts. Okay. So now here it forms. Yes. This is the area. This is the area bounded by chord and arc. Area bounded by chord and arc is said to be segment of the circle. Yes, and another segment is there. It's also segment. Yes, so smaller one is called minor segment. Smaller one is called minor segment. Bigger one is called a major segment. Yes, minor segment, major segment. So next is sector. Yes, see now. Yes, OP is a radius. OP is a radius. OB is a radius. Yes, this part is said to be sector. What is this? Arc. Area bounded by 2 radii. Area bounded by 2 radii and an arc is sector. Yes, and here also the same. PYB. So minor sector, major sector. These are the terms related to a circle. Then again, so many important parts are in the form of theorems. Is it that we want to see? Next one is angle subtended by a chord at a point. Angle subtended by chord at a point. How do we define the definition? Chord is the line segment which joins any 2 points on the circumference of circle. Yes. Yes. O is center of circle. Now AB is a chord. AB is a chord. Yes. Now angle subtended by chord at a point. So now P is any point. P is any point on the circumference of circle. So now you can tell angle subtended by chord AB at P. Angle subtended by chord AB at P means in the major segment or major arc. Yes. Similarly, Q is any point in the minor segment or minor arc, and also we can tell yes, angle AQB is angle subtended by chord AB at Q. Means you can tell minor arc, you can tell minor segment. How these angles are there, that we can study in the next part. Okay, only now angle subtended by chord at a point. So now center is there. Is it? Here also can fall. Yes, it means here angle subtended by chord AB at the center. Yes, this is the point what we are going to observe. Understanding? APB is angle subtended by chord at P, it means major arc. Q is any point. AQB is the angle subtended by chord AB at Q, it means minor segment or minor arc. AOB is angle subtended by chord AB at the center. How these angles are in next part we will see them. Okay, so now next part is a center with circle center O. So now yes, AB is one chord, CD is another chord. AB is one chord, CD is another chord. Now the chords AB and CD are equal, it means equal chords. Yes. So now just I am joining AO and PO, and also I am joining here CO and DO. Then two equal chords are subtending angle center. Is it? Equal chords AB is equal to CD. Then they are subtending the angles at the center. Then what is the relation between the angles? That is in the form of theorems. So practically also you can observe, you can measure and tell. Means equal chords subtends equal angles at the center. That we have to prove in the form of theorem. Just can you see here now? Now, yes, AB equal to CD, AO equal to CO, AO equal to CO, is it? Can you reason? Radii of same circle. What you can tell about DO? Is equal to DO. Yes. Radii of same circle, is it? So now these two triangles are they congruent? Yes. Can you give reason? Congruence property, congruence postulates. Yes. Three sides of one triangle. corresponding to three sides of another triangle. It means by SSS congruence rule, these two triangles are congruent. These two triangles are congruent, then corresponding angles are equal. CT, corresponding parts of congruent triangles. AOB is equal to COD. Yes, it means equal chords of a triangle subtends equal angles at the center. This is the form of theorem. Let's improve that theorem. Yes, equal chords to circle subtends equal angles at the center. Yes. Statement that tells that equal chords of a circle is given. Two chords are given of equal length. Okay. Yes, EB and CD are two chords. Given circle with center O, circle with center O and chord AB is equal to chord CD. AB is equal to CD. Let's join OA, OB, OC and OA. Yes. To prove equal chords subtends equal angles at the center. That is, angle AOB is equal to angle COD. Yes. Proof. In triangle AOB and triangle COD, try to show them congruent. Okay. Now AB is equal to CD given, chord AB is equal to chord CD given, and OA is equal to OC, radii of same circle, and OB is equal to OD. Therefore, triangle AOB is congruent to triangle COD by SSS congruence rule. Three sides of one triangle corresponding equal to the three sides of the other triangle. Then the triangles are congruent. Therefore, angle AOB is equal to angle COD, corresponding parts of congruent triangles. It means equal chords of a circle subtends equal angles at the center. In this way, we are using the properties which are studying the congruence of triangles. Then we can prove. One question again. If two chords, not equal chords, if two chords subtending equal angles at the center, what about chords? Yes, can you tell? Two chords subtending equal angles at the center, then the chords are of equal length, that is corners of this theorem. Yes, so that you have to prove. Try to prove yourself. I will show how I am going to prove that theorem also. Okay, these are the terms related to circle and properties of chord subtending the angle at the center, angle at the circumference. Of course, angle at the center. Equal chords are subtending equal angles at the center. Okay, thank you.